All right, good evening, everyone. If you're active, indicate that you're active online. All right, guys, good evening, everyone. Please, if you're active, indicate that you're active. We're about to start a class tonight. If you're active, indicate that you're active. 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 Please indicate that you're active. Indicate that you're active if you're active. If you're active, indicate that you're active. All right, I want us to look at integration tonight. Our emphasis will be on integration. We have seen differentiation in our previous class. Today's class, we shall emphasize on integration. Integration as a reverse process of differentiation. Integration also means reverse process. We can say it's anti-differentiation. 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 Now, when I say integration, it is the reverse process of differentiation. Calculus is grouped into two. We have differentiation and integration. In our previous class, we have seen the various forms of integration, of differentiation rather. We have defined differentiation as the process of finding the derivative of a function, right? And we say we have different methods of differentiation. We have the power rule of differentiation. We have the first principle. We have the product rule. We have the quotient rule. We have the function of a function, also called the chain rule. We also talked about the implicit function. Then we classify differential values into two. What we say we have the explicit and the implicit function. But today's class, our emphasis will be on integration. This is the first class we are having. So I'll be building I'll be building our foundation rather in integration. So when you hear the word integration, it simply means the reverse process of differentiation. It means that when you integrate a function, a derivative of a function, the result will always result to the original function. All right. So let me take us back a little. In differentiation, we say we have the power rule of differentiation, right? Power rule of differentiation. Now we define differentiation as a system of finding the slope or the gradient of a function without plotting the graph. That if y is equals to f of x, then we say that to find the differentiation, to find the derivative of this function, it simply implies that dy dx is equals to f prime of x, right? Okay, this is the general way of representing derivative of a function. If y is a function of x, y equals to f of x. So find the derivative of f of x or of y simply implies dy dx equals to f prime of x. So the symbol used in representing differentiation, we say this dy dx equals to f prime of x. This is also equals to y prime. So when you see something of this nature, dy dx or f prime of x or y prime, that simply means derivative of a function. Then in the power rule, we say that if the value of y is given as x to the power of n, now to find the derivative of this function, we have to differentiate, right? That now implies that dy dx is equals to, the rule says I'll multiply the power with the coefficient of this x and subtract 1 from the power. That will give us nx to the power of n minus 1. This is the general rule of differentiation, called the power rule of differentiation. Okay, then let me give an instance to explain this. If I have y equals to 2x to the power of 3, that implies that dy dx is equals to 3 times 2 is 6x to the power of 2. This is my derivative of this function, which is 6x squared. Now, integration simply means the reverse process, meaning if we integrate this value, we'll fall back to the original value. Okay, but one thing I want us to understand is that differentiation always eliminates the constant value, meaning that when you differentiate a constant value, the answer is what? Is 0. So anytime you integrate, you have to indicate the constant value by using C. All right. So I will give us a general rule of integration. I'm just trying to remind us what differentiation is all about. Okay, so this is the derivative of this function, and we call this rule the power rule of differentiation. Now let's take a look at what is integration. We have defined integration as anti-differentiation. I won't go into detail of the introduction or what integration really is, but just note that the simplest definition you can give to integration is that it is the reverse process of differentiation, meaning when you integrate a derivative of a function, it will give you the original function, right? So it's called the anti-differentiation. It's a backward process that gives the derivative of a function. All right, so let's look at something. Look at this. We are saying that if y, right, is equals to f of x, that implies that dy dx equals to f prime of x, right? Good. Now, for us to integrate this, to fall back to this, after differentiating this, we have this. We can integrate this function and generate the original function. All right. So what we do is that we have to cross multiply this expression. We have to cross multiply. By the time we cross multiply this expression, that will give us dy times 1 is dy equals to f prime of x dx. F prime of x dx. All right. Now, to finalize this, we have to integrate both sides. Then we apply the rule of integration. We integrate both sides. The symbol for integration is this. This is the symbol for integration. So the integral of changing y equals to the integral of f prime of x dx, and this must be equals to f of x plus c. Please take note of this. The integral of changing y equals to the integral, because we are integrating both sides. After cross multiplying, we have dy times 1 is dy equals to f prime of x times dx. This is the derivative, right, of this function multiplied with ds. Exactly. So for us to generate y, because our goal of integration is to produce the original function, so I have to integrate both sides. By the time we integrate both sides, integral of dy is equals to integral of f prime of s ds, and that is equals to what? F of x plus c. Why do we have to put c? Because differentiation always eliminates a constant value. So anytime you integrate a function, you must have to end the results with c. All right, with c. But not all integration function. There are some integration function that you don't need to add c, like what we call the definite integration. Integration is of two types. We have the indefinite and the definite what? Integration. All right. When it comes to definite integration, we have two limits, the upper and the lower limit of integration. When we get there, I will explain. We don't use C. But for indefinite integration, we have to add C to the result. So why do we have C? You know, if we have Y equals, let's say, 2x squared plus 4x plus 6, the Y dx is always being a power rule of differentiation. That will give us 2 times 4, 2 times 2 rather, is 4x, right? Plus 4. When you differentiate 4x, the result is 4. When you differentiate 2x squared, the result is what? 4x. Then when you differentiate 6 is the constant, the result is what? 0. So differentiation always eliminates constant value. So that is why when you integrate a derivative of a function, you must have to add your C to this. By the time we integrate 4s, we'll fall back to 2s squared. When you integrate 4, the result will be what? 6. Sorry, 4x rather. When you integrate 4, we're going to have 4x. Then after integrating all those functions, I'll have to add what? C to it. That C represents that in the original function, we have a constant value, which we don't know. Are we there? So that is why we are adding C. Now take note that the derivative of a change in a variable is always equals to that variable. That is the first rule of integration. The first rule of integration, we look at several rules. The first rule of integration says that integration of a change in a variable is equals to that variable. What does that mean? Is that integration of change in x is equals to x plus c. Integration of change in h is equals to h plus c. Integration of change in t is equals to t plus c. Integration of change in y is equals to y plus c. Are we there? So anytime you integrate a change in a variable, you must always have the variable. Then we have to add what to it? C to it. That simply means that if I have an integral of 4 dx, that will give us 4 integral of the x, which is equals to, when you integrate the s, integration of change in a variable will always give us the variable, then plus c. This will give us 4 times changing integral of the s will give us 4x plus c, and that will give us 4s plus 4c. Okay, this is to tell us that whenever we integrate a constant value like 4, the result will be 4x. Are we there? Good. The result must be what? 4x. If I'm to integrate this, it means that I will have 4s. Integrating 4s, I will have what? 2s squared. Then I will have to add what to it? Plus c to it, right? Okay. Now take note of this. So that means that this expression here, since we say that integral of a change in a variable is always equal to that variable, that means integral of change in y will be equals to y, right? Y will then be equals to integral of f prime of x dx equals to f prime or f of x plus what? Plus c. So when we integrate change in y, the result becomes y equals to integral of f prime of x all in the s equals to what? F of x plus c. Please take note of all of this. Please, if you have come online, ensure you liked the video. Very important, like the video and share to your friends to also join us. Share, please share. Once you come online, like and share. Like and share, all right? Please, if you're active, indicate. Please, if you're active, indicate in the comment section. If you're active, indicate in the comment section. Let's share this video. Let this video go viral. Let's share it. Now that we have seen the first rule of integration, the first rule of integration, the first rule of integration says that the integration, right? The integration of a change in a variable equals to the variable. This is the first rule of integration. We are saying that a change, I've already explained that before, a change, integral of change in h is equals to h plus c. Integral of change in x is equals to x plus c. Integral of change in y is equals to y plus c. Please take note of this. A good example, if we're asked to evaluate the following, evaluate I equals to integral of 5 dx, 5 dx. Now, if we are to solve this, the first thing we need to do is to bring out the constant value. The integration, we are integrating this change in x. I hope you're aware, we are integrating the change in x. So what we do is to bring out this constant value. It means my I is equals to 5 integral of what? Of ds. So this simply means that 5 times integral of change in x. Integral of change in x, what do we say is the result? Is x plus c. So that means this expression becomes I equals to 5. This is times x plus c. And that will give us our I equals to 5x plus what? Plus c. So this implies that integral of 5 dx equals to 5x plus c. Please take note of this. This is the first rule of integration. The first rule of integration. Please, if you are active, indicate. If you're in the comment section, please indicate that you are active. Indicate that you are active. Indicate that you are active. If you are active, please indicate that you are active. Okay, the second rule of integration, rule 2, says integral of x to the power of n dx is equals to x to the power of n plus 1. Sorry, guys. Divided by n plus 1, then plus c, where n is not equals to minus 1. Where n is not equals to minus 1. Meaning, if I have a function of x raised to a starting power, to integrate this, the law says I will add 1 to the power of n and divided by the resulting what? Power. All right? Okay, we say that under differentiation, if I have 2x to the power of 4, to differentiate, the rule says the y, the what? The x equals to, I will multiply the power by what? Coefficient of x, meaning 4 times 2, which is 8. Then subtract 1 from 4, which is 4 minus 1, which is 8x to the power of 3. But when it comes to the power rule of integration, this is a power rule of integration. The rule says integral. This sign means integral. Integral of x to the power of n ds equals to x to the power of n plus 1 divided by n plus 1. Meaning I will just add 1 to the power and divide by the resulting power, then plus c. Anytime you integrate a function, always add plus c to the function. where the value of n is not equal to what? -1. Okay, let's look at this. This sign is called the integration sign. Integration sign. Integration sign. Our n represents the power of the function. The function or the exponent, right? X to the power of n. The x represents the integrand. The integrand, meaning the function we are integrating. That is called x to the power of n. Okay, but delta x represents change in x, change in x, or change in variable x. All right. YC represents what? Our constant. C represents our constant. So take note of all of this. Now let's see some example here. Example 1 under the power rule. If we are given this, evaluate the following, integral of x to the power of 4 dx. The right to integrate a function is always multiplied in form of change in that function. Like the authority to integrate x to the power of 4 is dx. If I have du here, I can integrate this. I have to look for a means to introduce what? Dx. Okay, so I have the right there. So anytime you are giving change in x to the power of 4 dx, it simply means I have to use the power rule of integration. But before you integrate, always look at this change in the variable given. Are you there? If it corresponds with this, then we can integrate using the power rule of what? Integration. So what we do here is to solve. The value of I equals integral of x to the power of 4 dx equals, so the rule says what? I will add what? 1 to the power of n and divide by the resulting power. So that will give us x to the power of 4 plus 1 over 4 plus 1, then plus c. So the value of our integral becomes x to the power of 5 over 5 plus what? C. Or I can express this as I equals 1 over 5 x to the power of 5 plus what? C. So this is the value. This is the answer to this. Let's see another example. If I have this, we are asked to evaluate integral of 4x to the power of 3. 4x to the power of 3. Solution to this, let's integrate this. Solution, our integration equals integral of 4. Sorry, this should be in the x. Integral of 4x to the power of 3 dx should be equals to, now if I'm to integrate, see the power rule says integral of x to the power of n dx. It simply means that I will express the whole of this to be in this form. So what do we do to make this look exactly like this is that I have to factor out. I'll bring out this 4, okay, at the back of this integral sign. So here becomes 4 integral of x to the power of 3 dot what? Dx. Then I can integrate this. Are we there? So this and this are now alike. The number here attached to this integral sign is what? Is 1. I hope we are aware in the general form, the power rule of integration. So before you integrate this, you have to bring out the constants before you integrate. So that will give us what? We have 4 times, here we have x to the power of 3 plus 1, okay, over 3 plus 1, then plus c. So this will give us 4 times x to the power of 4 over 4 plus c. So what we notice here is that 4 can actually go with 4. So the final answer here becomes, the integral I equals x to the power of 4 plus c. This is the final answer. X to the power of 4 plus what? Plus c. Okay. So let's move on. Let's see more example. Please, if you're active, indicate that you're active. If you're active, indicate that you're active. Okay, let's see this example we have here from our note. Here we're asked to evaluate integral of 4x cubed divided by 7 dx. 4x cubed divided by 7 dx. We're asked to integrate this. Okay, solution to this. The same way we solve, the general form of this is integral of x to the power of n dx. So I'm going to express this in this form. Means I have to factor out 4 over 7 out, right? So that implies that integral of 4x to the power of 3 over 7 dx is equals to 4 over 7 integral of x to the power of 3 dx. So this will give us 4 over 7, okay, times, integrating this will give us x to the power of 3 plus 1 over 3 plus 1, then plus c. So our final answer becomes, our integral sign equals 4 over 7 x to the power of 4 over 4, right? Over 4, then plus what? C. 4 can cancel out 4 from here. So that will give us our integral equals 1 over 7 x to the power of 4 plus c. Final answer. 1 over 7, or we can say x to the power of 4 divided by 7, then plus c. Okay, so let's see more example. We have a question here that said integrate this or evaluate this. Evaluate integral of 3x squared minus 4x plus 2 all in dx. Okay. In this case, we have more than one terms, right? We have 3x squared, we have minus 4x, we have what? Plus 2. Why integrate? I would integrate each of these terms, okay, individually. So this can also be expressed as integral of 3x squared minus integral of 4x plus integral of 2 all in what? All in dx, right? All in dx. Okay. So, or we can just go ahead and integrate. Let me just move ahead and integrate instead of going through this process. So our integral becomes, integrating this to give us 3x to the power of 2 plus 1, right? Divided by 2 plus 1 minus 4x to the power of 1 plus 1, okay? Divided by 1 plus 1. Then plus 2x. The power of x here is actually 0. So this is like saying 2x to the power of 0. X to the power of 0 is 1, right? 1 times 2 is still 2. So if I have a constant value this way, this simply means 2x to the power of 0 dot what? Dx. This is same as 2 dx. So if the power is 0, so I will add 1 to the power divided by what? 0 plus 1, then plus c. Don't forget. So our integral becomes what? Here will give us 3x to the power of 3 over 3 minus 4x to the power of 2 over 2 plus 2x to the power of 1 over 1, then plus c. So 3 can go with 3 here. 2 here 1, 2 here is what is 2. So we have x to the power of 3 minus 2x squared plus 2x plus c. This is the final answer. The final answer here. Okay, so let's look at this is final answer. Let's solve something else entirely. Please, if you are active, share the link right now to your friends. Share the link, share the link, share the link, share the link, share the link. Okay, please, if you're active, please solve this for me in the comment section. Sorry for that. Okay, to evaluate this can also be expressed as I will factor out 6 over 5, then integral of x to the power of minus 7 dx, right? Minus 7 dx. So when you factor out 6 over 5, the result remains 1 over x to the power of 7, which is also same as this, right? So our final answer becomes 6 over 5 times x to the power of minus 7 plus 1, right? Minus 7 plus 1 over minus 7 plus 1, then plus c. So here we have 6 over 5 x to the power of minus 7 plus 1 is minus 6 divided by minus 6, then plus c. So 6 can go with 6. 6 can cancel out 6 here. We are left with our I equals minus 1 over 5. 1 over 5 x to the power of minus 6 plus c. This can also be expressed as minus 1 over 5 times 1 divided by x to the power of 6 plus c. So the final answer becomes I equals minus 1 times 1 is minus 1 divided by 5 times x to the power of 6 is 5x to the power of 6 then plus c. This is the final answer. This is the final answer. Okay, let's look at another rule of integration. Another rule of integration. Integration of inverse linear variable. Integration of inverse linear variable. If we have an integration of 1 over ax plus b, this will give us 1 over a ln ax plus b, then plus c. I'm going to explain this so you understand what I'm doing. Listen, integration of inverse linear variable. Inverse linear. All linear equation or function are of this form. Y equals to ms plus c, right? A linear function is a function with the highest power of 1. So whenever you see an integral of inverse linear variable or linear function, we have to use the word lin. Either, for instance, integral of as plus b is equals to 1 over what? A ln as plus what? Plus c. So that implies that if I have, okay, let me show us how we actually come about this. I think that would be the best. If we are asked to integrate or evaluate this, please pay attention. Evaluate integral. Okay, integral of 1 over ax plus b dot dx. All right. Now, the first thing we need to do is to introduce what we call u. We also call this direct substitution. Direct what? Substitution. Direct substitution, or the u method. The u method. Okay? The u method. But the most important thing is that it must be of this form: integration of inverse linear variable. All right? If it's not inverse linear variable, it will be a different method altogether. I will give us some examples so that we can see how we can express this. So if we are given this integral of 1 over as plus b ds to integrate, so we call it the u method. We say let u equals to as plus b, the variable, the linear variable. So if u equals to this, I have to differentiate u with respect to what? To x. Don't forget that a and b are constants, right? So when we differentiate the u with respect to s, the result becomes only a. B will be 0. Integration of a constant is 0, right? Every constant have a derivative of 0. If I'm to differentiate 2x, the answer is 2. Differentiate 4s, the answer is what? Is 4. When you differentiate 2, is 0. Differentiate 4 is 0. So when if I differentiate ax, I will have what? A. Differentiate bs, I will have what? B. Right? When you now differentiate a, the answer is 0. Differentiate b is 0. All right? Okay. So I'll say let u equals to what? As plus b. Then I will differentiate the u with respect to what? To dx. That will give us what here? A. That will give us a. Okay. I've already explained that here. All right. So since this will give us a, then here we have, let me call this equation 1. Then I'm going to make my dx as to stand alone as the subject of the formula. Okay, as subject of the formula, I'll make my ds to stand alone here. I can cross multiply by saying a times ds give us what here? A dx equals to what? Du. So the next is to find dx. I will divide both sides by what? By a. By what? By a. A can go with a. That means our dx is equals to du divided by what? U, right? Why am I making my ds as subject? It's because I want to replace my ds in this function with what? Du over what? U. The right, if I'm saying that let u equals to as plus b. Okay, I would have loved to show us something. Let me show us something. Just watch. Let me show us something. You see the same thing, but let me just show us something. If we have to evaluate this and we say let u equals to this, that means the function I becomes integral of 1 over u dot what? ds. Are you seeing it now? So here we have 1 over u, but we're having the s here. The right to integrate 1 over u is not the s. Anytime we are giving integral, anytime we are giving integral of 1 over x, the answer is ln x plus c. If we are giving integral of 1 over u, the answer is ln u plus what? C. Don't forget that in differentiation, we say that I give us a table of differentiation, right? If I have y and I have f prime of x, which is same as my dy, the what? The x. We say if we differentiate sine x, we have what? Cos x. Differentiate cos x, we have minus sine what x. Okay, differentiate ln x, we have 1 over what x. Differentiate exponential s, we have exponential what x. Differentiate tan x, we have sec square x. Now, if integration is a reverse process of differentiation, that means when you integrate cos x, the result becomes sine x. If you integrate sine x, the result becomes what? Minus cos s. Are you there now? If we integrate 1 over x, what will be the result? Ln x. So are you saying that from here, if u is equals to as plus b, this becomes integral of I equals to what? Integral of what? 1 over what? U ds. Meaning that by the time we integrate this, the result becomes what? Becomes ln x. So if I have 1 over u, I will have ln u. Okay, so integration is a reverse process. That's what I'm trying to say. But I cannot just integrate 1 over u and call it ln u when we have the x here. What I have to do is to look for a means to bring the right of integration. The authority to integrate 1 over u is not the s, but rather it is the u. So what do we do is that I will differentiate u with respect to x. So from that expression, I will now make my ds as subject and put it back in this expression here. All right? By the time we put it back in this expression, I will generate the right to integrate 1 over u, which is what? Our du. Now, see what will happen here. Now, I've cleared us why we say that integral of 1 over u will always give us ln. Okay, ln. Please take note of that. All right, so all right, let's watch and see. So let's call this equation 2, right? So I'm going to differentiate this now. I'll say du the what? The x. I've already explained how the result, right? The result here becomes a. Now let's make our ds as subjects. Making the x as subjects of the formula, of the formula. So here will give us, I will cross multiply, right? I'll multiply a by dx, then du by 1. So here we have a dx. A dx equals to what? Du. To solve for the s, I will divide both sides by a. So a can go with a. So we have our dx equals to du over what? A. Equation 3. Now what do we do here is to put equation 3 into equation what? 2. Don't forget that our aim of doing this is to eliminate this ds. By the time we replace the s as du over a, it means I can now integrate what? 1 over u, because the authority to integrate 1 over u has been generated. Right there. Now watch. So this will give us, I will say, put equation 3 into equation 2. That will give us I equals to integral of 1 over u dot what is our dx. The s is, this is our ds, right? The s is du over a. Okay, du over a. This is also same as 1 over a. 1 over u dot du over a is like saying du times 1 over a. So I can bring out this constant. The constant here is 1 over a, right? Integral of 1 over u. If I'm to bring out 1 over, if I have du over a, this is same as du times 1 over a. So this 1 over a is what I have to factor out here. Okay, by the time we factor out this, we still maintain 1 over u, right? Dots. Since we have factored out 1 over a, what will remain here is what? It's just du. It's just du. So what does that imply? It implies that our integral becomes 1 over a. Integral. Now, we have been able to generate the authority, the right of integration. The right to integrate 1 over u is du. The reason why I have to go through this process, because from here, if I'm to integrate this, I can't integrate it because I have the x here. I have 1 over u and the x. This is change in x. This is change in x. So anything you must have to integrate must have the same variable in this change. Are you there, somebody? So that is why I have to just eliminate this ds by replacing it with what? Du over a, in order to generate the authority or the right of integration. Okay, so here we have. Now I can now integrate. Integral of 1 over u is ln u plus what? Plus c. So my I becomes 1 over a ln. The value of our u is as plus c. So I will replace my u with as plus what? Plus c. As plus c. Sorry, as plus b rather. Sorry, as plus b. As plus b. Then plus what? C. Okay. That is just that. That is just that. So this is the final expression. So integral of any of this function, if we have an inverse linear function, it becomes 1 over a, the first coefficient of that x, 1 over a ln the function itself, the integrand itself, plus what? Plus c. All right, so that it means, let me give us an example. What that means is, if I have integral of 1 over, let's say 2s plus 4 dx, the result becomes 1 over 2. 1 over 2 ln 2x plus 4, then plus c. 1 over 2 ln 2s plus 4 plus c. Okay, but let's do it in using exam standard way. If we are asked to evaluate this in the exam, please evaluate integral of 1 over 2s plus 4 dot dx. In the exam way, the same process we repeat. I will say let u equals to the linear function, right? 2s plus 4. So that means our I becomes integral of 1 over u dot dx. This is equation 1. This is equation 2. Then I will generate equation 3 by differentiating equation 1, right? I will say du over what? Dx is equals to what? 2. So the next is to cross multiply. That will give us 2 dx, right? Equals to what? Du. So for us to solve for the s, means I have to divide both sides by what? By 2. That means that my dx is equals to du over 2. This I call equation 3. Then I say put equation what? 3 into equation 2, right? Into equation 2. Into equation 2. Equation 2 says I equals to integral of 1 over u dot dx. So that will give us our integral equals to 1 over u dot our dx is du over 2. Is du over 2, right? Okay. So I will factor out 1 over 2. So my I becomes, the value of our I becomes 1 over 2 integral of 1 over u dot du. 1 over u dot du. So the right to integrate 1 over u is du. So that will give us our integral equals 1 over 2 ln u plus c. Ln u plus c. So this will give us I equals 1 over 2 ln. Our u is 2s plus 4. 2s plus 4, then plus what? C. This is the final answer. Final answer. Please take note of this. I think we can also express this as the final answer as I equals ln 2s plus 4 divided by 2, then plus what? C. Any of this, you are also correct. So let's see more examples. Please, if you're online, please indicate. Make sure you comment. Make sure you click on the like button. Please click on the like button. 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 Once you have joined us, please click on the like button. Okay, more example. More example. More example. If we have this function, evaluate integral of ds over 4x plus 7. 4x plus 7. If you are given this to integrate, it's still the same thing with the previous example under inverse linear function. All right, this is also same as r equals to integral of 1 over 4x plus 7 dot what? The x, same thing. Okay, by now we should know what the answer will be. The answer will be 1 over 4, right? 1 over 4 ln in brackets ln 4x plus what? 7, then plus c. Please take notes. This will be the answer, right? Now we say that the integral of 1 over ax plus b dx is equals to 1 over a ln ax plus b plus c, right? So both use the other method, the process I gave you to bring out your notes. But if we are to integrate this, it means 1 over 4 ln 4x plus 7 plus c. This is the shortcut, the short form. But it must be a linear function. Meaning I must have a linear function here, which is 4x. Okay. So let's see another example. Another example. Please, if you join us, make sure you like the button. Please, this helps us. It gives us more visibility, rather. It gives more visibility. Once you like the button, it gives more visibility. All right. So once you join, just like the button, like the video, rather. Click on the like button. All right. Click on the like button. So look at this here. We are asked to evaluate integral of 3 divided by 2x plus 1. Integral of 2x plus 1. Then, okay, 3 dx. 3 dx. Integral of 3 ds over 2x plus 1. This is simple. What we have to do is to express this in this form. 1 over ax plus b dx. I have to express this in this form. How do we achieve that? I will factor out this 3 and put it here, right? So integral of 3 dx over 2x plus 1 is equals to 3 integral of 1 over 2x plus 1 dot dx. Then I will say let u equals to 2x plus 1. If u equals to this implies that our integrand of 3 dx over 2x plus 1 is equals to, okay, let me use I to represent this. It implies that I equals to integrand of, 3, 1 over u dot what? Dx. Is that clear? We factor out this becomes 1 over u dot dx. So the next is this is our equation 1, is our equation 2. The next is to differentiate the u with respect to the x. That will give us 2, right? So by the time we make our ds as subject, we should know what the result will be. By the time we make the s as subject, we're going to cross multiply. That will give us 2 dx equals to what? The u, right? So that means our dx is equals to, our ds is equals to du over 2, right? Du over 2, this is equation 3. So I'm going to say put equation what? 3 into equation 2. Okay, equation 2 says that I is equals to 3 integral of 1 over u dot dx, right? 1 over u dot dx, and this will give us 3 integral of 1 over u dot our dx is du over 2. Du over 2. So I'll bring out 1 over 2. 1 over 2 times 3 will give us 3 over 2. So our I becomes what here? Becomes 3 over 2 integral of 1 over u dot what? Du. So I can then integrate this. So the result becomes our I equals to 3 over 2 ln u plus what? C. This will finally give us I equals 3 over 2 ln. Our u is 2s plus 1, then plus what? C. Okay, what does that mean is that if we are giving this, let's say 3 over 2s plus 1, already 1 over 2s plus 1 will give us 1 over 2. So what do you do? Multiply that 1 over 2 by 3. That will give us 3 over 2. Then attach what to it? Ln 2s plus 1 plus C. Just like that. Without this 3, it will be 1 over 2. So since we have 3 here, I'll multiply that 3 by 1 over 2, which is 3 over 2 ln 2s plus 1 plus C. Just like that, as simple as. Okay, let's see one more example. One more example. Okay. We have to evaluate this function. We also evaluate this function. Evaluate integral of 12 dx divided by 6s plus 1 integral of 12 ds 6s plus 1. Please, you can pause the video and try this by yourself. Pause the video and try this by yourself, okay? All right, but let's solve. Solution. Now, if you look at this here, we have 12, we have 6. This should be 12 over 6 ln 6x plus 1, then plus C. Then that will give us 2 ln 6x plus 1 plus C. But let's solve it together. This will give us, I would say, let u equals to 6s plus 1. That implies that our integral I becomes integral of, our factor as this way, we have 12 integral of 1 over u, right? Dot what? Dx. Okay. Then we differentiate, we have the u, the what? The x to be equals to 6. I will make my ds as subject. That will give us du divided by what? 6. Right? the u divided by 6. So the next thing we need to do is to put this value. This is our equation 1. This is equation 2. This is equation 3. Is to put equation. We put equation 3 into equation 2. That will give us I equals to 12, right? Integral of 1 over u dot our ds is du over 6. So this will give us I equals to 12 over 6 integral of 1 over u dot du. So our I equals to 2 integral of 1 over u dot du, which is 2. Okay, let's apply it here. So I becomes 2 ln u plus c. So final answer becomes I equals to 2 ln, our u is 6x plus 1, then plus c. Please take note of this. Take note of that. Take note of this. All right, so let's look at the next rule of integration still under direct substitution. Still the u method. The u method. Please, if you are following, indicate in the comment section that you are following. Please indicate that you are following. Indicate that you are following. Please indicate that you are following. If you are following, indicate that you are following. Please indicate that you are following. Indicate that you're following. Indicate that you are following. Okay, let's see another rule. Integration of function of a function of linear variable. Integration of function of a function of linear variable. This is the reverse process of chain rule. We have learned chain rule method using differentiation. So we want to look at this. Okay. Want to look at this. This is a reverse process of chain rule, right? This is mostly used when an integrand contains composite function multiplied by the derivative of its inner function. Okay, it's mostly used when an integrand contains a composite function. For example, if we are asked to integrate this function, integrate 2x plus 5, integrate or evaluate, please take note, evaluate 2x plus 4 to the power of 4 dx. So this is function of a function. Okay, if we are given a function like this and we ask to integrate this, okay, we're going to use integration of a function of a linear variable or of a chain of chain rule of linear variable, still under linear variable. Please take note of this. Still under linear variable. All right. So what do we do here? We have to use the u method. It's just similar to the other method or the other rule we just discussed. So what do we do here is to say, we have to say let u equal to the co-function, which is 2x plus what? 4. If u equals to the co-function, that means my I equals to integral of u to the power of 4 dot what? dx. Integral of u to the power of 4 dx. Now, what do we do here? We have to look for a means to replace the s with the u, right? It's the u because the right to integrate u is not the x. So we then have to say this is equation 1. Equation 2, we then have to say that we differentiate equation 1, which is the u, the what? The x equals to 2. So from here, it means that our dx is equals to du over 2. Du over 2. So this is equation 3. Then we can say put equation what? 3 into equation 2. So I'm putting the s into this, and that will give us I equals integral of u to the power of 4 dot dx, okay, which is equals to I equals to integral of u to the power of 4 dot the s is du over 2, du over 2. So here becomes our I equals, I will factor out 1 over each, 1 over 2. I have 1 over 2 integral of u to the power of 4 dot du. All right, so when we get to this point, I will have to use the power rule of integration I taught us in this class, that we learned in this class, the power rule of integration. Please, I want to take off this. The rule that says that integral of x to the power of n equals to x to the power of n plus 1 over x plus 1, then plus c. I will use that rule here because this looks exactly like this. So the power is 4. It means I will add 1 to the power and divide by the resulting power. That is the power rule of integration. So let's apply that here. So this will give us, or you can tell them, recall that this is equals to this. So that means that our I becomes 1 over 2 times integrating this, give us u to the power of 4 plus 1 over 4 plus 1, then plus c. So here we have our I equals to 1 over 2 times u to the power of 5 over 5 plus c. All right, so this will give us I equals to 1 times u to the power of 5 is u to the power of 5. 2 times 5 is 10, 10 plus c. Final answer becomes our u. Our u is 2s plus 4. Don't forget, we say let u equals to 2s plus 4. So here we have u as 2x plus 4 to the power of 5 divided by 10, then plus what? C. Final answer. All right? Final answer. We can also express our answer in this form. Our answer in this form, 1 over 10 in brackets, 2s plus 5 to the power of 5 plus c. Please take note of this. Okay, the next question here we have says, we are already rounding up because we cannot exhaust all the rules of integration. And we have seen the first, second, and this is the third rule. Then in my next class, we'll go into other rules of integration, all right, of various forms. This is integration of function. We have integration of other forms by partial fraction, by polynomial function. We have many of them. We have exponential function, we have sine function of integration, we have tangent, and so many of various forms of integration which I'll be looking at. All right, okay, so let's proceed. Let's solve one more question from what we have learned so far. Let's solve one more example or two. We have a question that says that evaluate evaluate 6s minus 5 Evaluate integral of 6x minus 5 to the power of 8 dx. To the power of 8 dx. What do we do here? Is that with the same process solution, we want to say let u equals to 6x minus 5. 6x minus 5. So that implies that our I equals to integral of u to the power of 8 dots dx. Right? So the next is to differentiate u. We have du dx equals to 6. So this implies that our dx equals to 5. Sorry, equals to 6 divided by what? Du. Sorry. Our dx equals to du over 6. Du over 6, right? So this is equation 3, right? We have to put equation 3 into equation 2. That will give us I equals to integral of our u to the power of 8 is, okay, here we have u to the power of 8 dot our dx is du divided by 6. All right, so this will give us our I equals to 1 over 6 integral of u to the power of 8 du. So we have gotten the right of integration. So our I equals to 1 over 6 times u to the power of 9 over 9, right? Over 9, then plus c. All right? So the next is to multiply 9 by 6. That should be about 54. 54, right? 54. So 1 times u, or I, equals to u to the power of 9 divided by 54, then plus c. We know what to do next. We have to replace our u with 6s plus 5. So that will give us the final answer. Final answer becomes our I equals to 6x minus 5 all to the power of 9 divided by 54 plus c. Okay. 4 plus c. Okay, let's look at another example. Then we end this class. Then I'm going to give assignments that will continue tomorrow. All right? We continue tomorrow. Let's look at this question here. Another name for this is called by substitution. Please don't forget, by what? Substitution. Another name for this method is called by substitution. If we are given this to evaluate integral of 2x plus 4, 2x squared plus 4 dx all to the power of 2. All to the power of 2. How do we solve this? Now listen, most students will fail this because they will use the method we just learned. This is not a linear function. This method is the integration of function of a function of linear variable. Linear variable, these are variable with the highest power of 1, right? Like the general form is y equals to what? ms plus what plus c. For instance, if I have like 2x plus 4, this is a linear variable. But when it comes to 2x squared plus 4, this is not a linear variable. So what we do is that I have to expand this. I have to use the power rule of integration. Okay, I will expand this, then use the general rule of integration. So expanding the integrand, that will give us 2x squared plus 4 all squared equals to 2x squared plus 4 times 2x squared plus what? 4. Okay, please take note. I have a quadratic function here. This is not a linear function, so I can't use that to integrate. So I have to expand if I have something of this nature. So this will give us, let's expand 2x squared times 2x squared is 4x to the power of 4. 2x squared times 4 is 8x to the power of 2. 4 times 2x squared is still 8x to the power of 2. Then 4 times 4 is 16. I repeat again. 2x squared times 2x squared is 4x to the power of 4. 2x squared times 4 is 8x to the power of 2. 4 times 2x squared is what? 8x to the power of 2. Then 4 times 4 is 16. So this will give us 4x to the power of 4 plus 8x squared plus 8x squared will give us 16x squared. Then plus what? Plus 16. So this simply means that the integral of 2x squared plus 4, 2x squared plus 4, all squared dx is equivalent to integral of the whole of this, right? Integral of 4x to the power of 4 plus 16x squared plus what? 16. All in what? All in dx. Please don't forget. Take note of that. The reason why we cannot use the linear inverse, the linear function we just discussed, is because this is not a linear function. This is a quadratic function. The rule cannot work with this function. So we have to just expand. Even though we have to the power of 3 or 4, expand. Use a binomial expansion method to expand it. So after expanding the terms, then you integrate each of the terms. Okay, so let's integrate this. Integrating, then will give us, here we have our integral equals to, integrate this, we're going to have 4x to the power of 5, all right, over 5 plus, yeah, we're going to have 16x to the power of 3 over 3, then plus, if we integrate 16, I've already said it before, integrating a constant value, I'll just multiply x with it. I said whenever we integrate the x, the answer is x plus c. So if I have integral of 6 dx, it becomes 6 integral of the x, which is 6x plus c. Please don't forget. So integral of a constant value will give us that value times x then plus c. Are we there? So let's move on. So 16 will give us 16x. Then we have plus c. So, okay, we have plus c. Please take note of this. Please, if you are still active, indicate that you are. If you are following, please indicate that you are following in the comment section. Please indicate that you are following in the comment section. So let's move on. This is the final answer. This is our final answer. So we are done with that. So this is how to expand a function like this. Please take note. This is how to expand a function like this. If you are active, please indicate that you are still active in the comment section. Please indicate that you are active in the comment section. All right. Indicate that you are active in the comment section. Okay, someone brought a question to me at the tutorial and said I should assist him to integrate this. Then I said I'm going to solve it during the live class. The question is this. The question says evaluate integral of 8x. Okay, we have 3x squared minus 17 minus 7 rather, all to the power of 19 then we have dx. Someone brought this question for me and said, please, sir, can you integrate this for me? Now, let's see what we're going to generate from here. Solution to this question. Solution. Please listen, everyone. Now, the first thing to do is we are going to use that same direct substitution method. I will use the u method. I will say, let u equals to this. So say, let u equals to 3x squared minus 17. All right. That implies that our integral becomes integral of 8x, okay, dot u to the power of 19 dot what? Dx. Okay. If u equals to this, the co-function. This is similar to this is just like a function of the function, but not of linear word variable, right? Just say let u equals to this. So if u is this, that means integral of 8x times u to the power of 19, then dot what? Dx. Then let's call this equation 1. Let's see what will be the result here. I'm going to differentiate. I will differentiate this. I will look for a means now to eliminate this x from here. I don't need this x. My challenge will be this x. So I'll look for a means to remove this x. If you look at this now, when you differentiate this function, I will have a linear function. I will have 6x, right? X, by the time we put back the value of our dx into this function, s will cancel out. Let's watch and see. So let u equals to the co-function, this function here. Then our I becomes integral of what? 8s dot u to the power of 19 dot dx. So I will differentiate. I'll say du the what? The x will give us what here? 6x. Exactly. So from here, I will cross multiply. This will give us 6x dx equals to what? Du. The next is to find the x, right? So the x becomes du divided by what? 6x. This is our equation what? 3. I will say put equation what? 3 into equation 2. By the time we put equation 3 into equation 2, so that will give us our I equals integral of 8x, or let me just recall this, u to the power of 19 dot dx, right? So I equals to integral of 8x dot u to the power of 19 dot our dx. Our dx is du over 6x. This becomes du divided by what? 6x. So what we notice here is that s can go with x from here. So we're going to have our I to be equals to 8 over 6 integral. Okay, let's cancel out sometimes. 2 can go in 8. We're going to have here as 4. 2 can go in, we're going to have here as 3. So this will give us I equals to 4 divided by 3 integral, or I can say 8 over 6. Then later you cancel out. Any of them, you are still correct. The major thing is that we have been able to eliminate this x that will have affected the result, right? So this will give us 4 over 3 u to the power of 19 dot du. Then I will apply the power rule of integration. So I becomes 4 over 3 u to the power of 20 divided by what? 20, then plus what? Plus c. All right, so let's finish up this. 4 here is 1. 4 in 20 will give us 5, right? Will give us 5. Okay. Give us 5. Then 5 times 3 will give us 15. So our expression here becomes our I equals to 4 divided by 3 u to the power of 20. Sorry. We have already done the division. This will give us u to the power of 20. 3 times 5 is 15. 15, then plus what? C. So final answer becomes I equals our value of u Our value of u is, what was our u again? Sorry. U is 3s squared minus 7. So we have 3s squared minus 7 all to the power of 20 divided by what? 15, then plus what? C. This is the final answer here. This is the final answer. All right. Okay. So let's take note of this. Let's take note of this. Let's take notes. All right, so let's take notes. That's correct, right? That's correct. So that is the final answer. Okay, I'm going to pause here for tonight. Then tomorrow or next, I will announce my class. We'll look at integration of other forms. Integration of other forms. In my next class, we'll look at integration of this form. Integration of f prime of x over f of x, which is integral of du over u. All right. We also look at integration of u dot what? Du. All right, u dot du. We also look at integration of by partial fraction, also by integration by parts, So my next class we cover all of these forms of integration. At least we have seen the basic form. These are the basics so far. So please, if you have any question, you can drop the question in the comment section. But please, once you join this class, anytime you join, make sure that you like the class. Okay, just click on the like button so that we can have more visibility. All right, so thank you guys. Good night, everyone. That reminds me, tomorrow being Saturday at the center, we're having 5 hours marathon class in physics 102. 5 hours marathon class in physics 102 is a class we cannot afford to miss. So invite your friends and your colleagues. Okay, invite as many as you want to invite. Let them come for this class. So see you guys tomorrow at the center. All right, good night, guys.